Yo, 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 what's up, everybody? Welcome back. Today we are working on making a dev regex kernel module because I thought it would be funny. So, context is maybe a month or so ago, I saw a bunch of computers blue screening, right? The news is going crazy. They're like, nothing's working. My friend was at the hospital and he's like, dude, they have to like write down who's here on like a piece of paper. It's crazy. And it turns out that the problem was this like antivirus software. I don't really know what they do. I just, I'm kind of going off vibes. But like, I think it's like an antivirus software called Cloudstrike, and they had like a regex engine compiled into the kernel that was like loading regexes at boot time. And they were, maybe you could argue that that's reasonable, right? You could like see a world where the antivirus is like scanning for patterns and stuff, and like those patterns are matched by regexes. But the problem here is that the regex engine, under some cases, would just like blow up, right? And so like they updated the list of things that they're matching against, and then everybody's computer doesn't start anymore. And I see that and I go, wait, that seems kind of fun. Like, one, I've never written a regex engine before. I don't really know what they're doing. I know, like, in my head, like, I have some guesses about how it implements it, but I don't really know, right? And then two, I was like, doing it in the kernel is just really funny. I like that idea. So like, so since Linux can't blue screen, right? Which is the problem. The problem is the blue screen. We should do it in Linux, and then we can't have the same problems. We'll have different problems, but we can't have the same ones. So the plan is approximately, I want to create this like dev regex pseudo device driver. And I want to like open him and write stuff into him and read stuff back. And the idea is that we will get back the stuff that matches the regex. So we will do some like out of band setting of stuff to say like, hey, let's set the string hello world, right? If we see the string hello world in a line, then that's great. We'll filter that line. That's the plan. And so we've been kind of like working a little bit on this for the past few days. We've got to the point now where we have a kernel driver that creates that handle and sets up these operations. And what's a little interesting here is that we have been kind of playing with the idea of doing this in Zig. So we have this like implementation file in Zig that doesn't really do much right now. He basically just echoes stuff back. So he has like per file, he has like a buffer, and he just like on write stashes stuff in this buffer, on read sends it back out. That's all we do right now. We also have the ability to like, we have the ioctl set up to set the regex, but it doesn't do anything yet. So the plan for today is to actually make a regex engine, which I don't know how to do, but it will be fun. So step one is like, let's just start by like doing like just match the string. And then we can start like pulling in regex features, like, maybe start and end of line, like, which are like the caret and the $sign, maybe something where we can put like stars and pluses for repeat character matches, A or B, multi-character match, i.e. like, A, B, C, D in square brackets. We'll just kind of see, we'll just implement features and see what it makes the code look like, because we don't know. Yeah. So I think that's all we have to give for context. Let's just fucking start running it. So we are 3 minutes and 40 seconds of the stream, which means that I shouldn't just dropped an F-bomb because YouTube will demonetize me, maybe, but that's okay. Because we're not here for that. We're here for the fun. Okay. So let's start by basically when we set the regex, we should do something. So first let's make sure that we are actually getting that, because we went on this kind of side quest the other day that kind of made stuff not really kind of put us in a state where I don't really remember where we ended up. I have to reset this because every time I run QEMU, it fucks up my terminal, which is very cool. Love that. But it's okay. We'll live. So here we have regex. We copy this string from user space, or this structure from user space. We call dev regex impl set regex with that thing. So that should be in impl.c. And here we copy the data and the length from user, and we say got regex request for this. So let's pull open our test C file and just make sure that if we do something like something how do you do this again? Dude, my C knowledge is like gone. Car query or regex set, or yeah, we'll call this the regex string is going to be like hello from ioctl, we'll call it. And then we want the data to be regex stir, and this has to have like these square brackets after it, and then here we can say that we want the length to be size of regex stir. I'm pretty sure that this is right. I'm pretty sure that this gets inline directly, but I don't actually remember, and so we will find out in a second. We will find out very soon how fucking stupid I am. We'll compile this thing with gcc -o test.c with static linking because our kernel test environment has like no shared libraries. Because we're trying to do like the simplest thing possible, and the simplest thing is actually less simple now, but it was simple to implement, not simple to use necessarily. And then we will run this thing, which basically like starts up a virtual machine and copies in the stuff that I want to like a RAM disk that we launch in, that we like give to the virtual machine, that loads our kernel module and our test executable. And so now we do see hello from ioctl, which does mean that we are seeing stuff that we wrote. So it's a big win for us. Big win for us. And I think let's just we'll do something like for now. We'll just say please match hello, and we will write hello and goodbye, and hello again, and goodbye again. You know. And what we are hoping to see here is when we read this stuff back, we should see only hello and hello again. I guess we need to make sure that we do like the same thing where we have like query string is going to be basically whatever the fuck I wrote here. Bum, 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 bum. Query string. And this is going to be size of query string. And then here, I guess we will do the output buff. Can we do this? Is this legal? I actually don't know. But we'll find out in a second. I think it might not be, to be honest. We might have to malloc the output buffer. Yeah, I guess we'll see what happens. GCC run. All right, cool. So he says hello, goodbye, hello again, goodbye again, and we are chilling, big chilling. So now let's just do something. So here in our driver, I guess we want to kind of store some sort of representation of this regex. So I know that here we're only doing filtering, but I think that we should start kind of working towards what we think like a regex will look like. And so my thought here is that we're going to have like some sort of like matcher. And he's going to be like one of many types, right? So you can imagine like at the top level, if you had like match A or B, right? Like you're gonna have rules about like what thing you're on. So this kind of you're gonna have like something that looks like or, match, like match and match. I don't know. And then each of these is gonna be like its own thing. So if you had like, if you put the query like hello, this would be maybe be represented as like starts with, and then the string hello, right? Something like that. I don't know. And then like if you had, an end thing, you want like also like ends with, right? And then like maybe you have like full string for the case where you have both of these, or you could do something like and starts with ends with, right? Like you could represent it this way. And so like my thoughts are maybe we do something that's like matcher is a union, and this has like all sorts of types of things that you could be trying to match against. So the filter would just be like contains, right? Contains, and we map this to some sort of string. And then we can say like matches, right? And he's going to take in like a line. And this will just return like true or false. So then we can like switch on self, probably by const. And here we say like, if we are a contains, right? Then we just say like line stood mem contains index of, I think is actually how we are supposed to do this. Just index of pause. I think this is like what people use. Yeah, because we'll just return null if we can't find it. And so we can say we have like a U8 string, and we're looking for line in which way does this go? Haystack needle, so S in line, because the line haystack is line, needle is S. We're looking for S in the line, the needle in the haystack. Did you find out what was causing the stack corruption in the end? Yeah, so we found out that it was the Linux kernel compiles with all sorts of arguments. But I think that I think if we run our build here, we'll actually see what those arguments are. We're supposed to. Oh. Here? Reset? What's going on? There we go. Here we go. So it compiles with all sorts of arguments. But one of these arguments is, let's see if we can find it. Preferred stack. Stack. Here we go. Preferred stack boundary is equal to 3. And this thing says, hey, we would like for our stack to be aligned by 2 to the power of 3, i.e. 8, when we call things. And Zig is following this calling convention, sysv ABI, I think. And he says stacks are supposed to be aligned to 16 bytes every time I call. So Linux kernel arguments are like kind of specifically overriding that thing. And that was causing some like misaligned stuff to be called, because then the Zig compiler, like Zig compiled code goes like, yeah, this thing has to be at this alignment. And then that constraint was validated. So that was what was causing the problems yesterday or Saturday. Fun little thing. Fun little thing for sure. Okay. And then I just fixed that yesterday with this, like, I think that this isn't like quite correct. Mlug kind of indicated that the compiler is not really guaranteed to do what I want here. But I basically just threw something on the stack at 16-byte alignment, ask the compiler not to optimize that out, and then call a function. So every time I call into Zig now, I just call it 16-byte align and just hope for the fucking best. This has led to my latest Zig proposal. Let's take a look. Hell yeah. So, sick. Remove set stack align, add a new syntax functions in call conv. Oh, that's kind of neat. Call conv C, incoming stack align 4. Yeah, that sounds kind of nice. Pretty cool. Nice. Appreciate the movement on the Zig side for my bugs. Didn't mean to look too comment. Yeah, it's okay. It doesn't matter. All right, but back at it. We need to focus. Focus the fuck up. Lock the fuck in. So here, we are basically going to try to compile this regex that we got from the user, and turn it into one of these. So I guess this is going to turn like into like something that's like compile. And this is going to take in a regex. I'm kind of borrowing terminology that I've kind of seen in the past, right? Like I don't really know. I've done like zero research into how to write a regex engine. I guess I asked ChatGPT, how do you do it? And then he gave me like these like 3-letter acronyms, and I was like, I don't know what either of those mean, but I would do this. And he's like, that was one of the 3-letter acronyms. I'm like, oh, sick. Okay. Works for me. So, but what I'm going off like things I've seen like in Python regex module. I seem to remember the terminology they use is compiled regular expressions and matchers. That's, yeah, here. So like pattern is equal regex compile pattern.match. This is kind of like where I'm borrowing the thing from. And if you think about it, like what we are doing is we are turning a like string into some sort of like rules on how to execute stuff, right? That's like kind of what we're doing. And so compile here, I think, is like a reasonable term to me. We compile the string into a matcher. So now the question is, what the fuck do we do? Since we only support contains, this is a very simple compilation. In fact, all we do is we say return contains is equal to the regex, right? Something like this. I can never remember the union syntax in this language, but I think it's like this. And then just when we are either reading or writing, probably reading, we probably want to read like line by line, right? So maybe on read here, we're gonna say like, well, I guess the file data needs to contain like a matcher, um, which I guess could be unset, right? So if it's unset, we just kind of return everything, or we ditch everything. One of the two. Probably ditch everything. Um, I guess you could argue that we should be kind of running the regex on write because then we're not like buffering stuff that we don't need. But in reality, this is like a fucking toy, so I don't care. So something like GNU NSP, I think that is when I asked ChatGPT how people write regex engines. I think I saw the letters NSP and I was like, I don't know what that means. Is it this? So I think yes, maybe. I don't know. Okay, so we'll do it on read for now. And I guess we will just kind of buff. We will kind of say that if we do not have a line end, then we do nothing, right? Because we want to run these regexes on like a line by line basis. So yeah, I think that's reasonable. You could do character by character matching here. Like our matcher maybe should kind of take like an API that's like push, and then we can like get the thing out. But for now, I think that we will just do it line by line, and if we want to change it later, we can. So we'll do here. We'll say what file buff index of items. So we want to like find new lines, I guess. So it's like file std mem index of scalar. We want to be like, is there a fucking new line in this thing? Right? That seems reasonable. So we look in the buffer items and we look for a new line. Right? If new line pause, then we do something. I guess it's like if new line pause, I'm going to call this new line pause opt. So I can do if new line pause equal to null and just say if there's no new lines in our like buffered stuff, then we just like get the fuck out of there, right? So we say like return 0. We did not read anything. There was nothing to read. I don't know if we're supposed to return E again or something in this case. I'm pretty sure that if you like read here, the expectation is that if it returns 0, it's empty. 0 indicates end of file. Yeah. So we are successful in this case. It just means that there's nothing to do. How will dev regex work? Like cat pattern dev null, cat input dev null. More. So yeah, here we'll open up we'll show you the thing. I'm expecting to basically set the regex out of band with an octal, and then write stuff to it, and then read stuff back, and only get the filtered stuff. Top tip: instead of doing this, you can do or else return 0. That makes more sense. I'm down. I agree that is just better. Okay, so now we have a new line position, and then we kind of say that we are going to, I guess, match that thing. So I guess I was gonna say, do we copy the thing out? Now we run it in line. So we say file matcher, if file matcher, we say, does it match? If the matcher matches from file buff items from 0 to the new line pause, then like we return that thing. So this is kind of interesting because they might have said like, hey, can you give us like 4 bytes of stuff here? And if our thing matches like 100 bytes of stuff, then we kind of have to like buffer that thing. So I think that we actually kind of have to do like in buff here and then out buff. And we'll check if the out buff is null or empty, then we do this. But if there's stuff in the out buff, then we just like immediately send that shit out. I think that's fair, and I think we don't. It's okay to not fill this thing all the way up. If they ask for 10 bytes and we give them 5 bytes, but there's more left, I don't think that they have to. Like, I don't think that we have to give them everything that we're capable of giving them right now, which means that this makes this really easy, right? We can kind of say like, file out buff I guess we copy that stuff. So we do like dev regex copy to user. We have like some stuff in kernel space. We need to put it in user space. So this goes to pointer, and we take from file out buff items, right? Dot pointer, because we're calling a C ABI, and we need to copy some length. So we'll call this like a copy len, and the copy len is going to be the smaller one of the size of the buffer that we're copying to, or the size of the thing we're copying from. I know, it's crazy. It's crazy. We're getting crazy out here. Okay, and then after we do this, we have to basically like shift our buffer. So we have a copy backwards here. Arguably, it's stupid to contain like hold this stuff in an array list when we should just like maybe have some sort of circular buffer. But if I remember correctly, I'm not the biggest fan of the ring buffer type in the standard library. I guess for this case, it actually does make sense because it's like I think that my issue with it was that it's hard coded for U8s and not growable. But both of those things are actually probably fine for us, but I'm still not going to use it because I'm already here. We're already at this point, so we're going to do it this way. And then we resize this thing to copy len. And maybe it makes sense for this. We make a little like shift function, shift buff, because we're going to be doing this many times. And so we will say that this is like takes in some like array buff as an stood array list u8 pointer, and we basically just do this boom boom boom, and we need to shift it by some amount. So this is buff items amount, and buff resize buff items len minus amount. All right, so now we can do shift buff of out file out buff like this, boom, and by our copy len. Cool. Which means we can kind of do this down here too. And this is actually the in buff now. I don't know. We should think about everything else we were doing before is probably like not reasonable anymore. Probably. All right. So here, if this thing matches, we basically copy that part to the output buffer, I think. So here we actually need to return. So if this is not equal to 0, not if it's equal to 0, we copy from the output buffer, and then we just return copy len. Then we are done. But now if we get past this part, that means that we have no output stuff to send. We look for the new line in the input buffer. And if it matches, we basically copy that stuff to the output buffer. So here we say file outbuff append slice, basically this thing. So maybe we should say we can kind of put this here as like a named thing. We'll call this like the next in line. Okay. Then we can do next in line and next in line. This is kind of fun. There's next in line. No, next in line, next in line. I feel like there's like multiple ways that you could interpret this that are almost all correct, but I've changed my mind. I think they're not almost all correct. We are too stupid to figure out how to handle errors here, so we're just gonna catch panic and say fix me. And I guess we should just return -1 or like negative e something, right? So fix me e no mem or something. I don't know. Like we should do something, but instead we just crash our kernel because we can't blue screen. So we've kind of, we have nothing to worry about. Okay. Then we need to shift our in buff by that much. So shift buff file in buff by next in line length. And I think these actually have to be ampersands here. I don't know why they're not. And then if we've done that, we can kind of actually just fucking like call ourselves again, which is kind of funny, right? Because this stuff is at the top. And so we now know that there's stuff in there. But what happens? I'm not sure if that should happen here. What happens if we have no matcher? If we have no matcher, I guess we just return 0. There's nothing. We can't do anything if there's nothing to match against. So I think that's fair. What if we have a matcher and it doesn't match? Then we kind of want to do all of this stuff in a loop, right? Because we need to match. We need to go line by line until we're either out of space or there's something to. So here, this should actually be if file. Yeah, I guess we'll do while true, because here we need to say this kind of handles the like exit condition. I guess you could do it this way. You could do while this new line pause. Sure. So while we can find a new line, we do this, and then also this shift is actually wrong. This needs to be +1. This needs to be +1 because we need to shift the new line out as well. Okay, so if it matches, then what? We, I guess, just send the line out. Dev regex impl read file with file pointer and size. Right, because now we just go here and then we're chilling. Maybe fix me, I guess it makes more sense to factor this stuff out. I don't like the idea of recursing. I hate it. I hate it. So we'll say function like propagate output buff or something. I don't know, man. I guess this could be like a member of file, to be honest. There's no reason for it not to be. Function send. Write output or something. I don't know. Read output buff. Sure. Self takes in file, and then we have pointer is some U8s, and len is a U size or something. This is called size before. And this returns a U64. Okay. All right. And then this is return self read or file read output buff of pointer and size. Catch, panic, fix me. And it's the same here. Perfect. Perfect. Yeah, I think that might work, to be honest. So in our little test thing, we should see that we get hello and hello again printed out when we run this. Assuming that we built this. And we built our kernel module. We don't need to run less here. And our kernel module doesn't build because we suck ass at programming. So 116 here. This just needs like in buff, I guess. Everywhere on write to the device, we just write the in buff every time. Every time it's in. Okay, there's still some buffs kicking around here. Yep. Still some more. File.buff 108. God. I guess we need to initialize the output buffer here too, actually. It's a really good point. And matcher has to be initialized to null. All right. No field name buff. That's true. We don't really need this or this. We are kind of done with the Stack Overflow or like segfault errors. Copy to user. He's mad about something here. I actually don't know what. Oh, yeah. Okay. Fix me. Do something with this return. But for now, we are going to pretend that there's nothing to do. No field name buff, again, at 141. So that's true. So this is at read file. Next in line is from the in buff, not the out buff. And then switch, he's mad at 82. Why does he need another thing here? Else prong required when switching on type const thing. Is it because I'm supposed to do self.start here? Yes, and then 84. That's true. I did just ignore this. So return this is not equal to null. Boom. Boom, boom, boom. All right, let's see what happens. It sounds like I can hear my fans just like cranking. Right? So QEMU is just eating CPU and nothing is happening. So the question might be why? Um so he got the regex request. I guess we should find out maybe if we go into test.c. It must be we must be in read here, right? If we do printf reading and then done reading, I think we will see that we are just hot looping here. We didn't compile our code before we run it, so nothing happened. But we could try now. So yeah, he's saying reading, and then he is doing nothing. So my assumption here about returning 0 here must be wrong, right? So I bet if we go into our read file thing here and we just say like print k, returning empty, right? I bet we're gonna be hitting this, or it's actually more likely that we're hitting this. Where we have to shift this thing no matter what. That's actually probably more likely it. Because we were just kind of like hot looping, being like, I swear to God, there's more stuff. Okay, so he's still mad, actually. Which I actually didn't expect there. But we do also see that this is not being printed. So can we just kind of say here, like, loop, please. And let's see what happens there. Let's see what happens there. Run. Loop, please, yeah. So really, we could just fucking use a debugger like real people, like real developers, you know? Let's try that. Let's try that. So we can go to our test kernel env run script, and here we just type, oops, he's mad again because my terminal emulator is fucked up because something printed something that it shouldn't have, and nobody fixed it, so we have to type reset. But we say here, hey, QEMU, could you start up a GDB server and kind of tell us what's up? You know, just kind of like let us know. Let's get into a shell here that has the stuff that we need. We need the default environment plus GDB. We don't have GDB in our environment, so give me 1 sec. Next shell GDB, and now we can go into our kernel build folder and we copy the kernel module into this folder so that we can run this like GDB script that basically says like, hey, could you like load the Linux kernel as the thing we're debugging, then like add some like Linux kernel debuggy stuff, and then could you please try to connect to QEMU's GDB server? So now if I run this thing, he's gonna pause, waiting for GDB connect. I'd say gdb-x and run.gdb, and he goes like, yep, we're good to go. I hit continue, and then here I breakpoint, and we can say LX symbols, please. All right, and can we go like backtrace now? And we can see that we're in this print case. So we go to like frame 8 and just hit next here. We can kind of, maybe I have to finish a bunch of times. Finish. Where am I? Finish. Fuck. Break. Can we just breakpoint here so that we can continue until we get there? There we go. Next. So here we are saying that we did not match. Oh, did I just not compile this? Because it seems like the else prong just is not getting hit. Hello, AAX. There we go. It could be that I made a change while my terminal was messed up and I didn't notice, or I forgot to recompile. Both of those things are very frequent. Sometimes I forget to save as well. So this looks a lot like we did, in fact, write our little else prong. And then I ran make. Okay. Zig build did, in fact, run. We did, in fact, get our new thing. So I'm actually a little confused here. Run. And then quit. Copy. GB. Continue. And then breakpoint. LX symbols to get the thing to load. And then do we still have that like, oh fuck, oh fuck, oh fuck, oh fuck. Can we just continue now? Backtrace. Break on this, I guess. Continue. Next, next, next. Okay. So yeah, here we shift. Okay, so this is good. So pfile.inbuff. So there's a lot here. So it looks like we're not shifting. What the fuck? Can we break on that? Like, what the fuck is going on here? Pmatcher. Pfile.matcher. Okay, that's... Oh, this is not set. That's kind of interesting. So here we're actually getting into the case where file.matcher. Oh, so we're just kind of like looping, hot looping here, being like, we can't do anything. So here, if there's no matcher, we should also return 0. That makes sense. That makes sense. And then we should also set the matcher, to be honest. So when they set the regex, we have to do like buff 0 len is our regex. And we have to do like matcher compile this. And then we say file matcher is equal to this. All right, let's try that. Make. And pointless discard. That's true. A little whiner this guy. And then let's go back to our run script and disable GDB because this makes it a pain in the ass. Okay. Make run.sh. Okay, so he got regex request for hello. He said reading, freeing, reading, done reading. But then it also kind of feels like we didn't get anything. You know? It does kind of feel like that. So can we see... Yeah, we see done reading, and we were supposed to try to print this. So here we also have to say, like, int red. Okay, dude, fuck red and read being the same spelling. Because it means that, like, this name collides. Also, it's like, I read this as int read. So, num bytes read. Like, and I guess they say while... We'll probably just like while num bytes read is equals 0. We do this. Num bytes read is equal to 0. And this is actually while it's not equal to 0. We read this, and then we print that stuff. Can you print with like a... I guess you just are supposed to like memcopy. Include... What the fuck did I just do? Include string.h. Here, can we just like memcopy to standard out? Like, what is standard out? Is standard out a file? It is a file. So we actually have to do like f printf. Can we, I just want like, can I just copy to a file handle? Is that something I'm allowed to do? Memcopy file handle. Am I fucking pressing open? Int read it, of course. Of course. Mem copy to file start. Like, how do I just like, I don't want to like printf. I just want to like I don't want to mmap. I just want to like, is it F right? Yeah, F right. That looks right. For a non-native English speaker, read should never be the passive read. I agree. I agree. Also, for a native English speak. Man, 3F right, I guess. So we write to pointer size stream. Do you guys understand why you have like why there are so many APIs with this double size thing? Kind of pisses me off. Not gonna lie. Not gonna lie. Because I feel like it's like I don't really get. It never feels necessary to me. You know. So number. So this is size and number of elements. So our size is one byte, and we're copying num bytes read elements of them. Okay. And then at the end, I guess we printf a new line or something just to make sure. I guess the new line should be in there, so we don't actually have to do anything here. What are you doing? I know you probably asked that in like a what are we working on type of way, but it's funny in my mind to see like what the fuck are you doing? Like why are you like this? We are working on a dev regex kernel module. So the idea is that you say, "Hey kernel, could you please regex filter this stuff for me because it's fucking stupid." That's about the extent of it. So it looks like we got nothing. I'd be interested to see if we like maybe we should printf here and say like num bytes read like this. Because it's clearly not doing what I expect it to be doing. So I don't know if it's because on the first iteration, it's just we were getting through first iteration and returning nothing. So why is that? Why is that? Why are we returning nothing? Can you, for regex, I'm a native French. Can you explain more in detail what you use that for? We wouldn't use it for anything. There's no good reason to do this. This is really bad. We shouldn't do this. But we are doing it because it makes me laugh. So the idea is that we write into this pseudo device, we apply a regex to that pseudo device in the kernel, and then we read it back and we just get the filtered stuff. Okay. So something in here is returning 0. Could be this. Shouldn't be this. We should be hitting the matcher. So here we'll say print k, no matcher. No matcher, no good. What was the eventual solution for the alignment issue? I just threw this like call 16 align macro at it that like asks for a thing to be put on the stack. I think that's not very like correct, but it seems to be working. Seems to be working. I assume that if you are seeing that if you know that there is an alignment issue, then that means that you probably got pretty far in the stream. And so like I think we root caused it. Okay, it was just the fix is maybe a little inconsistent, but good enough for now. Okay, so he could be returning here because no new lines. So if I understand well, you turn all the freaking complicated stuff to better stuff. I don't know what you mean really, so I don't know. Okay, so here we said should be some stuff. Should have some stuff. And I think these are all of the return cases. So let's try just running this thing again. Run our thing. And we are seeing no new lines. No new lines. So why the fuck is that happening? Because we tried to write to this thing. So we are looking at in-buff items, looking for a new line. Okay, sure. So when we wrote the file, did we not write any new lines? We copied from user into this thing. The other way around usually. So we do non-complicated stuff to make worse stuff. That sounds right. Yeah, that does sound more correct. Okay, so why is this not doing anything. Out is file in buff items plus old line, right? So we're supposed to copy from user space into this thing. I guess here it might be interesting to write down what the current buffer state is. So we should be able to do. Can you print k with like a bounded size? I assume that print k just uses the printf formatter. In which case, how to get print k port format specifiers, right? Like, if I remember correctly, there's a way to like %s or something, and then you pass in a size and like a pointer and a length. Printf non-null terminated string. Yeah, dot star s with length first. Okay. So can we do like, this is nothing is equal to print k with percent dot star s of our current buffer. So file in buff pointer len, and then file in buff pointer. This should be in buff items len, sorry, and items pointer. And let's see if that tells us anything interesting. Is it normal that the more I watch, the less I understand? Also, I think that means that I'm not doing a good enough job explaining myself as I go. So we can try to do better. Here, can we say we wrote this, and we'll put it in quotes so that we can see our current in buffer. Let's do that. Then this will should tell us what we have to filter. So current in buffer, we have hello, goodbye, hello again, goodbye again. So that's really good. That means that like there should be some fucking new lines in here, and the fact that he can't find new lines later is a little concerning. It could, so there's a couple options here. One is that the file structure is not being preserved across read and write. But another option is that, no, I don't know. So I guess maybe it makes sense for us to on read also do this. Current in buffer for reading. Let's do that and just kind of see what that says. I forgot to compile. You have to compile your code. We say that all the time. CRLF rather than LF. But I thought that like, is it one of those fucking bullshit things where on fwrite or like on print on write, like it's converting new lines to RNs because of like some sort of lang stuff? I know I've seen that before where like if you open things in non-binary mode, then they I can't remember. Then like depending on your language environment variable, like stuff happens. I remember something about that in like CSpec. But we also shouldn't have any like language definitions. So I don't really know. I don't know what I'm talking about. But current buffer for reading also has that stuff. So the fact that we see no new lines and stuff, and there's definitely fucking new lines in there, it's like, what the fuck is going on there? Reset because my terminal's always fucked up. File in buff items. So if we can find a new line in here and we just can't, surely I'm just doing something fucking stupid in here, right? Right? He's like, num bytes read 0. No new lines. So we're just getting like right down here, returning 0. We're never printing other stuff. So this is just not working. But why? Why? Typecraft, thank you for the raid. What's up, raiders? Okay, so we need to fill you guys in. What we are doing is we are working on a regex engine that we're building into the kernel, and we are testing it by basically saying, hey, let's open this pseudo device dev regex, and we're gonna like shove some stuff into that thing. Then we're gonna say, hey, regex device, could you please, when we read back, like filter with this regex string? And then we then just try to read back. And the idea is that we're trying to be like Cloudstrike, our heroes. So The more he says, the less it sounds insane. I think it's pretty not sane. Like what we're doing is like fucking stupid, but it's fun. It's fun. So we're doing it for fun because I've never written a regex engine, and it's been a while since I've written some kernel code. So like the double whammy here is kind of fun. And we're currently debugging why the fuck our Zig code to match this is not working. Now I have to be suspect just kind of generally of all the Zig code that's being generated, because we have hit some cases now where, because the kernel is compiled with all of these like special constraints, it's like very much possible that like the assumptions that the Zig compiler is making when compiling are not being hit. So we have to be a little bit hesitant to say, well, if index of scalar is not finding a new line, that means that there isn't a new line. It doesn't mean that. It doesn't mean that. And so I wonder if there's like a way for us to kind of double check this. Like, could we do like for 0 to file in buff items len? Let's just kind of start here. Let's try writing this ourselves and see how it works. So we can look at this as going to be like I. And we're going to say file in buff items I. And can we like, first of all, let's just print K that thing. So we'll say, we'll print this thing as a number. I think %d is allowed. Do you have to %? I think %d is allowed here. And then here, do we have to like upcast this thing to an int for that to work? Print car as number C. My understanding of variadic arguments is that this is not allowed because this character argument is not going to be enough bytes. Largely for historical reasons, characters are small integers and all integer arithmetic is an int type provider software. Oh, right. There's some sort of like bullshit promotion. Variable array arguments. I think all get promoted to ints. Yeah. That's okay. Fucking crazy language, but it's all right. Okay, so we're gonna say this, and we are just looking for. We are gonna say. I guess we'll just look up man ASCII. What's the new line character? New line character. New line. Is it not in here? Am I fucking stupid? Maybe it's not in the ASCII table. New line, is it hex 10? New line car number 10. Decimal 10, got it. So we're looking for this thing to say car number. We're looking for 10, simple. All right, let's run our test. So there's definitely new lines in here, right? HELLO, new line. Okay. So what the fuck? Why is index of scalar not returning the right thing? Let's try writing 10 here. No new lines again. Very strange. Very, very strange. Ooh. What do you got? Do you guys think that we are hitting backend supports vectors? Oh, okay. Because we intentionally turned this shit off. Mug, are you still here? Because this seems sketch as fuck to me. I'm not gonna lie, because in our build zig, we intentionally turned off all of these like vectorized instruction stuff because the kernel doesn't back up those registers. I guess I should say that's what I heard, but I'm not really confident. I guess like I'm sorry, I trust Mlug on that one, but I didn't look it up. So this looks sketch as fuck, right, Mlug? This backend supports vectors. If we are stage 2 LLVM or stage 2C, it's true. And then this just like generates vectorized instructions. Because what's happening here is index, if I use std mem index of, I'm not finding a character that I can guarantee is there, right? I like iterate everything one by one. I look for new lines, it finds it, but index of scalar is returning null. And my gut says that shouldn't matter. LLVM should convert vector to non-SC in that case. Okay, cool, thanks. Thank you, that's good to know. In which case, we can just crack out the debugger then. Dude, it's so sick that I can just like ask you instead of having to check. Okay, but then we should just, I guess we should just kind of hit a breakpoint here and take a peek. Take a peek. Okay, so let's set up our run script to use GDB again. To be clear, it's not impossible that something's broken. Yeah, I understand. I just wanted to know if it was like guaranteed stupid, not like maybe broken. You know, like those are two different things. And I guess I shouldn't say that I assume anything will be stupid, but you know what I mean. Not as a dig at anybody who writes code. Just like I do stupid stuff all the time. All right. So why the fuck did that run? I thought I changed my run script there. Test run. I thought I changed this to use -s. I guess I didn't. Okay. Run.sh. That's unfair. GPT's way worse. Yeah. Mug GPT. Hell yeah. Okay. So let's run GB. Am I in the wrong folder? I am. It's a hard life out here. So we go back to our Linux buildster and run.gdb. We continue. We break LX symbols to get it to load everything that we need to have. When we breakpoint at this line, we hit continue again. We run our test script again. Okay, he's not breakpointing there, so that's fucking annoying. Can we like breakpoint on dev regex impl read? I think it's called. No, dev regex impl read file. Okay. Continue. Test. What the fuck? Okay, so this could be that I've done something fucking brain dead. Or it could be that I've like multiple runs of this might just not work. It's definitely possible. Okay, let's try so if I go here, I write test again. Okay, so that's interesting. So when I was running in GDB, this was cage faulting, but when I'm not running in GDB, then it's not, which kind of like points to maybe some sort of like interrupt handling incorrectness in the kernel driver. That seems very possible. Very interesting. Okay, can I like when I do this like GDB thing? Can I like force a load of the kernel module even if it isn't there yet? Because when I do like LX symbols, it like automatically figures it out. But I kind of want to like, before the module is loaded, like gdb qemu load.ko. Like, is that something we can do? LX symbols does it, but I want to do it before that, you know? I just want to do like offer it. Find module by name and return the module variable, return blah blah, find Linux task, ls mod, LX symbols. Yeah, maybe not. Oh, because I guess like it needs to map where the module is loaded into kernel memory, and if the module isn't loaded into kernel memory, then it can't do that. So let's go into our like init script here in our RAM disk and just not run the test. That way we can before we run the first time, set up our breakpoints and stuff. That seems reasonable to me. Okay, quit. And then we run oopsies, run.sh. Then we run gdb. Sorry, run.gdb. Then we continue. Break. LX symbols. Then we need to breakpoint on wherever the fuck we're actually trying to test, which was breakpoint in dev regex impl read file. Continue. Now we run our test. So yeah, very, very Very interesting. So just by having a breakpoint in there, maybe just by being in GB at all, disable BR. Continue. Oh, enable BR. Continue. Yeah. Okay. So this is a really good clue. Really good clue that something we're doing is just fucking dumb. It might not be dumb. It might just be that like we're missing something. But here it looks like when we are basically on read, we're writing out all that stuff to our printf buffer. And that is page faulting. Error code not present in page. Oops, 002. And this is in read file somewhere. I wonder if we're just like print keying too fast and that's not allowed or something. We could try. We could at least try disabling that print loop in the read. So on read, let's not do this. And maybe even not do this. Because that's where it's claiming that the problem is. So if we just get rid of the problem goes away, you know? If the problem's not there, the problem's not there. Okay. So continue. And run our LX symbols. LX symbols. Break on dev regex impl read file. Continue. Run the test. Very interesting. Very interesting. So this is definitely in the read file, and I also don't really understand why. I should be hitting this breakpoint before we even get here. Oh, I forgot to copy the latest version of the kernel module over, and I wonder if I even forgot to build it. That's very possible. That's very possible. I sometimes forget to build things, and I also sometimes forget to copy them. So let's try making sure that everything's in the right state, because otherwise our debug info might not match what we expect it to be, which could be fucking stuff up. So run.gdb, continue, break LX symbols, break on dev regex impl read file, continue, and run our test. There we go. Okay, so it was just something stupid was being done there for sure. So let's step into index of scalar and step into index of scalar pause and just try to see what the fuck is going on here. Info locals, info args. So we're looking for 10. We definitely have a thing that's length 41 and our starting is 0. So this shouldn't be happening. We should continue here. Let's just kind of see where he thinks that he's broken. So we're at 1244. Can we open up maybe another terminal where we can follow along in the source code? Print case surely doesn't have an inherent race. 1,000 kernel developing angles would cry. Yeah, angels would cry. Yeah, I mean, it definitely does have like locking and stuff, but I wonder if there's something about like if you set a breakpoint at a specific point and it like doesn't handle the signals correctly. It could also be that we're not handling signals correctly in our compiled module. Like, you know, there's all sorts of stuff that could be happening. What was I trying to do? I was trying to look at what the fuck does that function do that we're angry at? Index of scalar. So here he got down to 1244. Right, so he skipped this. This suggest vector length gave us nothing because we immediately jumped down here. And he's just iterating over the slice from 0 onwards, and he's supposed to return something if he sees it. So why the fuck is that not happening? Can we disassemble? Like, is this doing something that it shouldn't be doing? Like, we're kind of here, right? So he's kind of just going like, panic start greater than end. Okay. Panic on bounds. Right, so he's got some like bounds checking on here. But then does he like have like a ret here? Yeah, he does. So here there must be a jump somewhere out of this. But it's okay. So next, can we print slice? This is fine. Print I. PC, H, E. Can we just like L? Okay. 1, 2. This should be L again. This should be O. So the next one, 10. We should be returning J. Right? That's what should be fucking happening here. Okay. Oh. Okay. So we did find a new line. So I got confused. I thought we never entered this, but instead something else is happening. It might be that the matcher is never matching. But he did too. At 1, if matcher matches, P matcher matches next in line. P next in line. Oh, this we've already done the shift. So this is HELL. Yeah, this would have been hello. It's something here is a little bit fucked up. It could be that our shift buff implementation is fucking broken. So we're at 163 though. No matcher, no good. P file matcher. This is something. Okay, can we like step into this? So something about this looks kind of fucked up, right? They're saying like ain. Surely we don't have anything that's supposed to say ain. Can we go up one maybe and look at like in buff items, top pointer, and then like look at this like for like 35 characters. Gain. Okay. So, we've done something dumb as bricks. Right? That's pretty clear to me. So, it could be that when we shift buff, we're just like fucking stuff up, like hardcore. No pain, no gain, /n00. Dude, that's crazy. You actually got that almost right. No pain, no gain. Okay, so we have to figure out why the fuck that's happening. So let's just disable BR, continue, enable BR, right? And then we can then run this little test again. And we can start by like printing file in buff. So, in his initial state, totally reasonable, right? So then the question becomes, can we see like, okay, here if we say next inline, that also is, whoa. Oh yeah, that's fine. So we have this with length of 5, right? So we have our next inline is like a reasonable thing. And then in here we go to matcher. If we match, it looks like it thought we didn't match because we're at 159 now, which is a little odd. I would have thought that hello should have matched our regex of hello, but I don't remember what the maybe we intentionally didn't match anything. I actually don't remember. And then can we look at like what happens after the shift buff? So this should be printing by next in line len. So it should be shifting by 6. So after this, we should see goodbye. Right? That's what we should see. So if we do a p file in buff items, and we just try to like print this for like, 20 characters. So there, it's clearly done something fucking stupid. And it's... So we resized. I guess we should have breakpoint. We should have gone into this and seen if it was after the copy backwards or not. Because we're trying to shift by basically 6 characters. Dear streamer, read my message. Oh, you want copy forwards. The forwards with backwards is iteration order, not. Oh, fuck. Thank you. Good eye, good eye, good eye, good eye. I would have got there, but it would have taken like 25 seconds longer. So thank you, thank you, thank you, thank you. God damn it. God damn it. Okay. Uh, while we're here though, I suspect that the regex string of hello. It's interesting to me that this didn't match at all. More like shift buff. Oh, more like shift buff with all those gains. Shift buff. Oh, with two Fs, that's pretty good. I was thinking more like shit buff because it doesn't do what it's supposed to do. So I'm curious about why. First of all, this first string should have matched, which is kind of odd. I don't know why it didn't. But at the very least, it's not like fucking brain dead broken anymore. Maybe we should confirm. We should confirm. So I guess let's go back to maybe printing out on each line. Can we maybe say like, oh my god, reset. Here, maybe we can say print k. We can say this is equal to print k. Next line is this, right? And this is going to be percent dot star s, I think was what it was supposed to be. And then we pass in next in line len and next in line pointer. Okay. Then we check if this matches, and here we will say print k. We match. Okay. And else we say no match now. No match. Okay. And let's just see kind of what comes of that. Can we edit our run script? I don't need GDB this time, I don't think. And let's run run.sh. Okay, so run test. So reading, next line, hello, goodbye again, that's really good. But none of these match. But we have a register request for hello. So what the fuck is going on there? We're getting farther, but it's still fucking broken because this definitely should have matched, right? So why not? Fix my terminal again because it's always broken. And so return, this contains this if the index of this thing in our line is not equal to null. If the index of the needle in our haystack is not null. Failing to match the slash n, but even then it should be, I would think it should be okay. I think I want to just breakpoint here, to be honest. I think I just want to breakpoint there. So run, we turn back on GDB stuff. Really, I should just kind of say here, this all gets easier if, oh, never mind. I was gonna say like you could look for like debug and put the args in, but fuck bash. So I'm actually just gonna keep doing this. Okay, make. We have to compile the code. We always have to make sure we compile our code. And then we run sh. And here we make sure we copy the thing over. And then we run.gdb. Then we hit continue. And then we hit continue. We break LX symbols to get everything up where it's supposed to be. And then we break at this line. Continue. Then we run our test. Boom. All right. P line. PS. That would do it, huh? That would do it. If it's trying to match \300, it's very likely that we just forgot to allocate the string that we're matching. Like, very, very likely that we just forgot to do that. I believe you got it, old bean. All right, so I think it's just that when we called set regex, we just, like dumbasses, were like, this contains equals the thing input. But this is like a fucking copy from user pointer into this allocated thing. And then here we free it unconditionally. So I guess we just don't want to do that. I guess like this should like have like an error defer free or something, right? But you know, fuck it. And then also we need like a close function to free file start data because we have some allocations here that we're ignoring, but you know, what we do. We just ignore that for now. Quit. Ron.gdb. Continue. Test. Hello, no match. No match, no match. Did I compile? I feel like I compiled. But I actually don't remember. I guess we'll just do our test again. How do I want to do this? How do I want to do this? Run. Copy. GDB. Run. Elect symbols. Break on this again. Continue. Test. P line. PS. Okay, this is better now. Now we're trying to match against the thing that we want to match against. But it looks like hello has length of 6. So what's going on there? So we want like s pointer plus 6, I guess. Zeros. So he's trying to match. He's trying to match with nulls, which is fucking dumb as fuck. I reckon you've included a null alternative in length. Yep, it does feel like that, huh? And I guess the question is what is like the reasonable thing for our interface here? I guess it doesn't really matter what's reasonable. We just have to do the same thing on both, both the user space and kernel space. And so I think what I'm going to do here is I'm just going to write here, len without null terminator. And then, now it's my fault for in test.c including the null terminator. So here I'll do this like this. Anonymous gifter, thank you for the gifties. It's too Bob. I called it. Yeah, probably. Well, you called one thing, but I would like to say that when you called that, that was not the problem. Because at that point we were freeing memory that we were trying to use. So you were right, but only kind of. Now you sound like my wife. Well, if you're trying to claim credit for things that you are wrong about, she's kind of just right. Like, you're kind of just saying that your wife sounds like a correct person, is kind of what I'm hearing. Okay, let's try this again. One more time. Should we risk no GDB? I think we should. Fuck GDB. Who needs it? No match. Still no match. Very surprising. Very surprising. I thought we had it. Oh, I didn't compile the code that I wanted to run. In classic Spheraphoria fashion, we did not compile the code. So, it looks like this actually works now. It's hard to see in this pile of shit, but we do see that we have a hello here and a hello again here being printed by a user space app. So we can probably, how do we fix this? Test.c. Here, we should fwrite a new line here. Or I guess printf a new line is fine. And then we can also printf a matched like this. And that should make it a little bit clearer to see that it's working in our little test script. So ron.sh. I actually didn't compile it again, I don't think. Maybe I did, I don't remember. But let's just make sure. ron.sh and then test. So yeah, here we see matched hello again. Matched hello. And no goodbye. No goodbye again. Why do you not put your compilation to your run script? Shut the fuck up. Is there a downside to putting make semicolon cp dot and run? You guys, look, you guys. You know, let me suck. Okay. Implement simple filtering. We have done it. We did it. It took an hour and a half, but we fucking got there. So let's now try doing a little, let's try matching again, only if it ends in the word string again. So here, maybe we'll do Uh, we will make it so that we have again, goodbye, hello again, goodbye again. And then if we match against again $, then we should get it only the hello again and goodbye again should match. So in our current state, actually nothing will match, right? So if we run this now, we actually will get no matchies, right? No matchies at all. But we can fix that by implementing the feature. It's Leo. Thank you for the gifty. You guys are so nice today. Look at you guys. Look at you guys. Okay, so when we compile this thing, now our compilation has to become a little bit more complex, right? Now we need an ends with, right? And how does this work? How does this work? Is it valid? Is it valid to put an end thing if at not the end position of your string? I guess so, right? Because you could have a regex that's like stuff or stuff, right? Like this is totally a valid regex, I think, right? If we go to regex 101 and we do like hello or hello. Oh, I guess we want to do it as like hello or hello. And then we test in like space hello. So this matches. Yeah, so it's totally valid to have like this $. Oh, I guess we want like this. Maybe even like, yeah, okay. So this is valid. So we have to like find the $, figure out which section of the regex we're in, and then consider that at the end. If I do like this, I guess this is also technically valid, but it's just like we'll never ever match anything, right? To put like a $, just in the middle. So let's think for a second. If I have 1, 2, 3, 4 $, 5, 6, 7, 8. Obviously, this is not useful, right? But it might be useful to kind of have this as like a representable form in our matcher. So it's almost like we want sequences. It's almost like this isn't. This shouldn't be ends with, right? This should be more like there should be. We should be like sequence, right? And in this sequence, one of the things that we can match is just end of line. Right? That doesn't seem crazy. So then we just kind of like, we say we match this, then we match this, then we match this. So that means that like when we're kind of, we walk our like input thing, and I guess this is this where lexers come in handy? You can omit the void? Oh, wait, that's sick. I didn't know that. Does that mean that okay, so I've been doing like this whole time too, where I have like return dot EOL is equal to this. Does that mean I don't have to do that? Like I can just write like return dot EOL? If so, I am angry that I've been doing it the fucking stupid way this whole time. So I kind of feel like we need like, is this where people talk about lexers? Holy shit. Hey, Poppy, thank you for the 5 gifties. What a nice thing. You guys are so nice. So nice. So here we're gonna have like, we're gonna go next. Next. And next we're gonna return something. Output. Some output of our lexer, I guess. And then we have like const output, I guess, is a union. Again. And he's kind of gonna return like stuff. Like I guess just like a string. Or he's gonna return like an EOL character. Right? I guess. And then we're just gonna use this to like, I guess we're just gonna like slap this stuff directly into the sequence. Seems reasonable to me to some extent. Seems reasonable. So here I guess we have like our self as Elixir, and we have like our input, right? And we have like uh what? Like I guess we consume until something. So we look for right now the only special character is a dollar sign. So I guess we have that like there's a thing that you could say like move forward until you find one of these many things. Holy shit. It's Leo, thanks for the 5 gifties. Thank you guys. Thank you. Thank you. Thank you. Uh very kind. I will yeah, I'm very very appreciative. What am I doing? Zig standard library. Zig standard library, lead page. And we are looking for documentation, and we're looking for like index of probably, and it's index of any is probably it. So here we're looking for any of these values. That sounds right. So we don't really need that right now, but we will eventually, right? So if we just do like start of line as well, then we can start looking at like stud mem index of any. No, backseaters get gifted subs. That's pretty funny. Zig SE hosts the docs locally and pulls them up. Oh, hell yeah. I've been doing it the stupid way. So we are looking in our slice of, I guess, input for one of like these, essentially, right? Our special characters. So if we have that, we can kind of inspect which one of those things it is, I guess. So you can say like switch, pause, self input, pause. And if we see a this, we return SOL. If we see this, we return EOL. If we see else, if we don't have any of our special characters, we just return S is equal to whatever, I guess self input. And on each of these cases, here we have to like defer self input is equal to an empty string, right? Which kind of means that like if self input is len is 0, we are done iterating. And then here we say self input is equal to self input from pause plus 1 onwards, right? No. Here we have our special characters. Right? We first have to check, I guess, if the first thing is one of our special characters. Which might be kind of silly because we've kind of already got that information from the next iteration. But that's okay. We can waste a little bit. We can waste a little bit, but that's okay. So so if is there like stud mem, like I assume index of any, not that like it really matters. I could easily do this loop myself, but I just want to see if this is, yeah, it's just a hardcode loop in there. That's fine. I guess we could do, we kind of do this. We could say if pause equals 0, this, right? Else we return s is equal to self.input up to pause, right? And then kind of in either condition here, we defer self input is equal to self input from pause plus 1 onwards. No, because in this case, that's only here we do that, and then in here we do pause. Yeah. This is super convoluted. Just do input 0 at the top. Yeah, you're right. I agree. Because yeah, I was thinking that we were already matching, but I guess that's yeah, I'm just brain dead. You're right. You're right. You're right. You are right. We would have got there, I think, but appreciate the pointing it out anyways. What's he mad about? This is a this and this is this. There we go. All right. All right, all right, all right. Does that feel right to me? This should be pause, not pause plus one. But yeah, that feels right. Feels right. Okay. So then this needs an allocator. So that we can allocate the matcher. Randomly fit around your stream and like how fast and smooth you navigate. Hey, man, I'll take it. I'll take it. Appreciate it. Um. Okay, so now what? We create our lexer, right? Var lex is a lexer. And I guess maybe we should just assume that we're always a sequence of matchers. That might make things simpler here. So maybe this becomes like a struct. This becomes like struct like this. And then here we can kind of make it so compile comes kind of at the struct level. And that kind of means that this union, I guess, is going to be called like something. Hold on, we'll get there. We'll get there. So this is going to be like a match item is one of these things. And so then at the top level, we just have like sequence is a bunch of match items. Okay. Okay. Switch cases aren't changing inputs, so you'll just get UL, 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 UL. Yeah, that's true. That is true. Do I want to do this in every case? Feels kind of silly, to be honest. I guess you could wrap it in a function, but I guess we'll just do it like this. Fine. I guess here we also have to check. No, we're gonna put in a function. There's stuff to do here, so we're gonna say function, inc and return, and this is going to take in self, right, as well as the item to return. So this is going to be output. And then you can do like self input is equal to self input 1 onwards, but this is only valid if self input dot len is greater than 0 or greater than 1. Otherwise, we have to do self input is equal to nothing, I guess, and then we return red. There we go. And then here we can do like self inc and return sol like this. There we go. There we go. Okay. So what we were talking about before, we were kind of like changing the way this works. So here we have our sequence. And okay, I'm thinking. Here our lexer gets pushed in with our regex. We say like for while lex next, we push stuff into our match sequence. So I guess we have like seek is going to be a std array list using of match items initialized with our allocator. Okay. All right. And then here on each item we say switch on the thing that we lexed. This feels a little silly, but because these lexers are 1-to-1 with our match items, but eventually they won't be. So that's why this is being done this way. Because like for like brackets and stuff, it will be different later. It will be different later. So I guess here if we get S, this goes straight to a seek append contains equals S, right? We have to try this, I guess. If we get SOL, this goes try seek dot append like SOL. Is this what we're saying we could do now? Okay. And then now what? Now what? This is now sequence is equal to try sequence to owned slice. Which means that this can fail now. So whoever compiles the matcher can now just say catch panic. No compile. And we'll say fix me. We should not panic, but we will get there later. Feel free to disregard this, but this is how I'd write this. Whoa, what the fuck? That's pretty crazy. I like understand what's happening here. I think I wouldn't do this. Not that I think it's wrong. Also, this is wrong, right? But you like just clarifying that this is illegal if input is length 0, right? Or length 1. Because I think I like this better, where I have like return ink and return, and then I just propagate the return value and do the length checking and stuff here. I could see that maybe that's like fucking stupid. Like maybe this is like inefficient in some way. But I assume the optimizer will figure it out. I assume. Anyways. Well, the point is that in the if it happens, yeah, I gotcha. If only happens if the switch give you back something. Oh. Yeah, I gotcha. There should still be an input length check. My bad. Yeah, I got it. No worries. That's not the point you were trying to make, so it makes sense. Understood. I like see why you do it that way. I think that like just stylistically, I wouldn't do that unless there was like a performance reason to. Even though it's deduplicates. There's something about like maybe it would be fine if I pulled this out. There's just something about like this that feels like a lot for my head, my poor stupid little brain to take in, you know? Okay, so now we need like a matches on here. This takes in our matcher. And now he has, his like S. But now he kind of has to do like. That's fair. I'm desensitized to that kind of nested control flow. That's fair. So here are like matches for the match item. Kind of needs to contain where it matches. Right? So, because if we're trying to do like a match sequence, we have to know, okay, so we found this thing. And now we're trying to get on to the next thing. So there's something interesting here too. Where if you have like A, B, C, star, followed by 1, 2, 3, 4, you kind of have to like, there's this ABC star could match all sorts of places, right? But this 1, 2, 3, 4 can only be in like one spot. So there's kind of something like, you almost need to go character by character, see if you start with a match and then continue on. I think I've been reading about some stuff recently where there's like ways to optimize that. Like when I was looking up like substring matching algorithms. And there's like some stuff about like Boyer Moore string search where they like pre-process this thing in some way to know how many characters to jump on each type of match and stuff. So we could do something like that. But I think for now we can just do like a brain dead thing and just go by character and see if this matches like right off the start. I think that's gonna have to be the play. So here we're just gonna do starts with instead here. So if return this starts with, otherwise it doesn't match. So maybe we'll say like Matt starts with as well. We'll kind of do this. Then we can do like SOL here. And then we can do this actually doesn't work either. Because here SOL should only match if it's the first thing in the item, or if the first thing on this, how do I say this? If we have not indexed at all. So maybe here we need to take in like our index as well. Maybe we get the full line, as well as like start pause, like this. So here, this just returns start pause equals 0. And then EOL is equal to return start pause is equal to line len. That kind of feels okay. And then here we just need like start pause onwards. And then this is a little tricky because start pause can now be the line length, right? So this isn't really technically always legal. So we have to say if start pause is less than line len, then we do this. Else return false. The idea of capture groups might be worth embracing. Maybe return them. Yeah, I can see that. But I kind of want to. I kind of want to start here. I don't want to like get overly complex before we see any progress, and I think that just makes things harder. Maybe I don't know. We're kind of just going and seeing what happens. So here, I guess we just have like what we have like our position, right? And we have like, I guess we have like the sequence pause as well. So this is gonna like string pause and sequence pause. I guess we kind of could just iterate the sequences. So for self sequence match item. Wait, what did I say before? I said we have to start looking at each character. That is kind of what I said. Which is stupid. I understand that that's stupid. Right? There's certainly optimized ways of like, if you know that the thing ends with EOL, you should search backwards. If you know you start with start of line, you should start at the beginning. But we're gonna do the stupid thing first. So we're gonna say for 0 as len, right? Then we do this. Okay. Yeah. This is stupid as fuck. Stupid as fuck. Don't judge me too much. You can judge me a little bit, but not a lot. Start pause. And so then we'll say that like this string is going to be S from start pause onwards. Okay. Then we have match item starts with, and we look at this S from start pause, string pause. If this is not true, if this is not true, we like continue the outer loop. Does it like continue block like this? Label not found, block. I guess it's here. So if this is not matched, we continue and we start from the next character. Implementing regex, just import RE, bro. That's not the point. That's not the fucking point. We want to do it ourselves because it's fun. This is the fun part. Um, okay, and then now what? Now what? Starts with if this happens, then I guess our string pause plus equals maybe we'll say this is like u size that it comes out. Right? So here he returns if start pause equals 0, he returns 1. He's like there's one character consume. Same here, right? If this return 1, otherwise return null. This is null. And this is if this, Jesus Christ, this is getting gross. Return len minus start pause, otherwise return null. I guess. I mean, that's kind of gross. I don't really like this at all. I'm not gonna lie. Maybe we'll go back. We'll go back. And we'll say consume. Okay. Or like num bytes. And we don't even need either of these, actually. I don't think. Because here we have contains is like how much we should advance by. No need to blame Jesus for your shit code. Okay. Sorry. Yeah, this feels better. So this is gonna return a U size, and it's like contain switch self. And if it's contains, we return slen. If it's sol, we return 1. Or eol, we return 1. And then here, we just advance by that many bytes. So we say string pause plus equals num bytes, and seek pause doesn't need to exist. And then if we get through all of these, return true. But then here, this continues a problem. Right? Because here we need to say, like, if the last thing matches, return true. But if the last thing... Oh, no, because if he doesn't match, then he continues. So this can just be false. Return false at the bottom. I'm pretty sure that's right. Right? Because we will all... If we ever hit something that doesn't match, then we will go back to this. Then we will exhaust this loop and return false. I think that's okay. Maybe. It's not like guaranteed not to work. Well, it might be. From my perspective, I'm not convinced that it won't work. Okay, so match your matches, expect to type this, found that. So that's kind of fair that like this probably can be by const reference. 2 arguments found 1 at 307. So he does need an allocator now. And here, probably like fix me, don't forget to free. But whatever, you know, it's fine. Output defined here at 108. Ink and return. This should return output. That's a good point. Starts with in match item. Really? Yes, there is. Oh, match item. Match item. That's one thing. That one gets me all the time, where I forget to change the first argument, and the compiler error is kind of confusing to me. Like it's one of those ones where it's like, I should fix it. Okay, so hello again. We match. Goodbye again. We match. That's again, goodbye, no match. Guys, it's working. Dude, that works. The again $ is matching on things that end with goodbye. It's working. It's working. So let's try now. We'll do one that's just again. And we will test that it is starts with again and ends with again. So now the only one that should match is again. Test. So that's not good. So we say hello, match, no match. Again, goodbye, no match. Next line, again, no match. Hello again, we match. Goodbye again. Match, hello again, match, goodbye. So we've done something wrong here. We've done something wrong here. I just want to confirm that I did compile everything. Oh, because the start of line is broken here. Because this matches needs to actually not start from this string. He actually needs to give S and string pause kind of relative to start pause like this. Otherwise, it doesn't know if it actually matches the start pause in the string or if it's the start pause of this particular iteration. Right? Because before I was doing like match ASDF, match SDF, match DF, match F, which means that like on every single one of these, like this one it thinks the first character is A, this one it thinks the first character is S, this one it thinks the first character is D, but in reality we should still be checking if the first character is like actually A. So that should do it. That should do it. Run. Test. So this time we got no matches on anything, which is an improvement. It's not really the best, but it's an improvement for sure. So can we check here and we can say print K. Let's say that here we're about to look at looking at this, which is going to be S len minus string pause, and then we're going to look at S from string pause onwards. This is a stupid way of doing this. To print is this, and then we will do to print dot len to print dot pointer. That's much better. And then here we will say looking at this with this, and here we want to use like can I do like a conversion from like any type to string with some sort of zig built in, or is that only, do I need to use like a buff print there or something? Type of like name, I think it was like there's like error name, tag name, type name. Yeah, none of those really match up what I want. So I guess if we want to stringize this thing, we do like std format buff print any the match item like this, and then we like say var buff is like 1024 UH or something. Probably can get away with like 512. Probably can get away with like 64. We call this the like const type name is equal to try this catch just nothing. I don't give a shit. I guess here we can just return buff in the case where this failed. Yeah. And then we'll just print the first like n bytes of it. And then here we have the same thing. Well, yeah, I think we have the same thing. So type name dot len, type name dot pointer. Okay. So this should tell us which matcher we're trying to match which segment with if we did this right. More likely, to be honest, is that we're gonna crash. But you know, it's fine. We forgot the buff here. You should just make stood loggies print K. Oh, that's so much smarter. Yeah, you're right. You are right. Yeah, that is just way fucking better, huh? How does that work here? If I'm doing like a build obj, is this considered the root? I guess it would be. I guess it would be. So here I can just do like pub const stood options equals struct, like equals stood options, and then we can do what's like log function is equal to something is equal to kernel log or something, right? And then we can do like, God, I hate it when you're just like, you should do this and you're right, right? Because I like to be like, fuck you, I'll do what I want. But at your suggestions are often just like correct. So here, I guess before we do this, we need some sort of like kernel print that takes in any string. Right, and this goes to print K of basically this shit that I've been printing, right? This s.len, s.pointer, right? And then even here, I don't even need to actually hook up the log function. I can just call whatever, like, there's a way to hook this up. How did I do this in like the WASM stuff? I've done this over here before in zig or index.zig. You can look very similar, where we had log wasm takes print format args. Format just does a buff print. Oh, right. Okay. Yeah, works for me. Works for me. So it's just buff print slice, and then if it failed, I just gave up because I'm a lazy piece of shit. I know that that's handleable, but you know, shut the fuck up. Okay. So here we had kernel print takes this and prints it. So stood format buff print s buff comp time args any type. So this is a comp time s, and then we say var buff is like 4,000 U8s or something, 1024 maybe, and we buff print s and args, and then we get the slice out. So const s is equal slice, I guess, and catch buff, and then we do slice here. All right, that's probably good enough. I don't even have to hook up kernel log, to be honest. I can just type kernel print instead of doing print k everywhere. We will try it here. So this is going to be a kernel print looking at this with this. Hell yeah. And this is a to print, and I guess match item. Run. Test. Oh yeah. Oh yeah. Oh yeah. You are right that that is just way nicer to work with. So let's look at the again. So looking at again with SOL void. Looking at gain with SOL shouldn't increment. SOL should not increment. That's the bug. That's the bug. Because the start of line does not consume a character. The end of line does consume a character because we have to end up past the end, but start of line does not. Matched again. Let's fucking go, baby. Let's fucking go. Okay. I want to do one more feature. One more feature, because it is 4 o'clock now, which is when I usually end, but I don't feel good with the clickbait of the YouTube title unless we do one more, right? Sick with a bunch of dollar signs and carrots is very funny. So I think we will do one more so that I can feel better about my YouTube video. So let's do. We can do either or pattern matching, repeats, or multi-character match. Kind of down on multi-character match, to be honest. I'm kind of down. So multi-character match. He has these rules that basically say if I have A, B, C, or D in these square brackets, I'll look at any of them. Which means that we kind of have to look for this. And if we have an open brace, then we're going to parse this stuff differently. And I guess the lexer, if we have like a lexer and a parser, it's actually fine for this to just kind of tag this as like match group open. I think that's not the right term, right? What is this thing called? Regex. ChatGPT will tell me. What do people call the characters in a regex? Character sets. Yeah, okay, sure. Character set open, car set closed. Two steps say I should say character class, but I like the word. I don't like using the word class in code, even though in this particular scenario it would be fine. But it's just like I don't like the keywords. They're too close. So calling it set feels better to me. Okay, so this is just return self inc and return car set open, and this is car set close. I haven't ever really written like compilers and stuff, so this is just kind of in my gut. Feels like how it should be done. But I could also see the argument that this we could just like straight up parse the whole thing here. But whatever. So we also have to be careful here. We actually have to keep track of if we are in one of these already, right? If we are in a character set, I don't know how that's supposed to behave, right? If we do like regex 101, if I do like, A, B, C, D, right? And then I put an open brace in here, the open brace just counts as one of them. So I guess here, interesting. So I don't really know in like compiler design, people like split up lexer and parser, and here I don't really know who's supposed to be responsible for like detecting this double open, right? Like it kind of feels like you kind of have to know your parser state in order to figure out whether or not this thing is true. So it's almost like it feels to me like it belongs in the parser. Like you just kind of like backtrack it if you see it again. But then like I think that you're also kind of supposed to discard character information as you go. Like you're kind of supposed to like not really care about like which exact characters you were looking at once you get out of the lexer. That's just like what my gut says. Although I don't fucking know what I'm talking about, right? Let's just be very clear about that. But yeah, it's fine for now. For now, we'll do it this way. Or we just ignore this problem. I kind of like that because I don't have to think about it. Not thinking, it's kind of like our thing, so if we get car set open, here we basically do like, we kind of like keep advancing the lexer until we see a car set close, right? So here's like we almost want to do like like compile compile car set or something given our lexer. Seems reasonable. So then this is like our car set is equal to this, and this can be like maybe like parse car or like consume car set. Feels kind of more like the right name here. Okay. So then we have like function consume car set, which takes an lexer. And he says like while lexer next item. he's going to return something at the end of here. It's certainly going to be a bunch of characters, right? Certainly. Certainly. And if we switch on the item, I guess here, like, all of these characters are no longer like special in this scenario. So it's almost like here we want to take in like a like oh god. It's like here you want to say like which characters am I looking for? Right? Like here we almost want to say like something like this, right? Parser state almost like hmm hmm yeah, I mean, I don't know. I mean, again, like, who knows what people normally do here? But my gut says that, like, we're gonna have like a different set of special characters depending on what parser state we're in. So it's almost like the Lexer weirdly has to be aware of our parser state, and that's maybe okay. It sounds fucking stupid when I say it, but it feels okay if I just disregard everything I've heard in my life. And let's just do let's consider it that way, right? Okay. So if we are in parser state of if we are in the parser state of char set, we are going to basically just consume until an end bracket. If we kind of have like none would be like kind of like our default state. Maybe we call it default. Default char set. Yeah. Is it legal if we like kind of do like this with nothing? Yeah, it does seem like okay. So in default state, we actually don't want to check the close item. So it's almost like we want like function find special cars given our state. Here we could actually do like find special cars. Maybe this should be like default. And this kind of does this, right? Sorry, I'm thinking. So kind of like both this thing and this thing change, huh? So we kind of want to want to do like process special char default, which does kind of this, and then we have like find special chars default. Maybe, I don't know. I don't know. So in default state, we kind of return this. And like process special chars, we do this. This returns like an optional output. So this would then like return null, right? Then here we can kind of like switch on our parser state. And if we're in like default, we do process special chars default. And then here we can do like if special ret is equal to this, and like if special ret, we just like fucking like send it. This doesn't seem like crazy to me. It doesn't seem crazy. Right? And then here we have like const like next special pause, right? Right? And then we say equals switch state again. And on default, we do find special slash default, and then in like, if we're looking in char sets, we only have like std mem index of scalar from u8 self input of just this, right? Then we have like next special pause like this. Right? Right? That doesn't seem like not seems like not fucked. So now we just have to handle like the char set. And here we just only have to do like what, like block? If self input 0 is equal to this, break block self inc and return char set close. Yeah. Else break block null. That seems fine to me. Like, not crazy. So then here we call next with default, and here we call next with we're parsing a char set. Yeah. And here it should be we either get a string, in which case we use that string, or it should be, honestly, the expectation should be that we first get a string, right? This should be all of the items in our character set, and we should get the close set, the close after, right? And if this is not closed, then it's like an error. So if close is not equal to this, a return error invalid char set, right? Then we have this, if s is not equal to s, we do the same thing. And then at the end of this, we just return s, like this. Right, am I crazy? That feels like it kind of works. Kind of works. Then here, we just return a char set item. Yeah, that seems okay. It seems okay. And then here we just do like try seek append. This is tried as well, and it's just char set equal char set. Oh, dude, whoever said that I should pronounce it Charizard, not Carzard, and is gonna like lose their minds that I alternate. It's like, who fucking knows which one I'm gonna say? I just realized I've been saying them both. So, sorry. Get fucked. Okay, and so then our like kind of top level matcher is gonna say, does this starts with anything in this char set? And we're just gonna look at like, I guess this can only return one character right now. That's how this works. And so here we can just kind of say like return if start pause this line len, else return false. Otherwise, you just look at line start pause if this matches any. So stood for this should have the set, right? For item in the set. If line start pause is equal to C, return true. Else, return false at the bottom here. If none of them match, then we have a fucking problem. Okay. And then num bytes is car set is 1 byte. 1 byte. Unconditionally. Unconditionally 1 byte. And maybe this compiles. Probably doesn't. Enum missing name, 90. Oh. I don't put dots there, that's true. Switch must handle all possibilities at 16. So here, car set close is invalid. So return error, no. Yes, invalid close. This can't happen here. Because when we're in default state, we never return that. We don't return car set close unless we are parsing car sets. Yeah, should be. We'll see. There's all sorts of ways that it's possible I fucked this up, to be honest. But it feels kind of okay for now. It's not .s there. It must be It is .s. So why is this not okay? If s this would be or else return invalid car set, I guess. That's fine. And this, I guess, is true as well here. All right. So let's just run what we were running before, and nothing is like crashing, which means that we haven't done anything that breaks the stuff that worked before. And so now, can we go into like test.c and look for like, maybe we look for HEL followed by A, B, or C, right? This should not match anything. Oops, it's GCC. Run. So here we should see no match, no match, no match, no match, no match. Right? So no match, no match, no match, no match, no match. But if we now put in an O with these A, B, C, we hope to see that it does match. That's what we're hoping. We're hoping for. So we run test. Oh, that's so fucking sick, man! Let's fucking go! That's so, look at that. Oh my god! Isn't that sick? Isn't that sick? It fucking works, baby! Hell yeah. Alright. So is device actually just something as abstract as has input or output? Or something I'm not grokking how regex functionality is a device? So, sorry, brain. I don't know, is the answer. That is how I am envisioning it right now, but it's very likely that the definition is less strict than that. Let's see if we can look at, maybe we can go look at the interface and kind of look at, you know, when we create a CDEV, like, what is on these things, right? So you could, for example, allow M-maps and not allow reader writes. You could probably allow ioctals and not any reads or writes. Like, I think that it's kind of more like fulfills this interface, where this interface is like stuff. I think generally the expectation is that they kind of act like imagine like you're reading your file system and you like you can like seek, you open your disk and you seek to this byte and you write there. You would kind of like expect that would open, like, write that offset on the bytes of the platter. That's kind of like what you would expect, right? If you were to read, like, write to dev null, you kind of expect that you can write to it, but like they won't go anywhere. If you read from dev random, you can kind of assume that like you expect that you read there and you get randomness, and if you write there, nothing happens, right? So I think it's like, it's kind of like not super well defined. I think of it as like I want to do IO on a thing, right? So like you have things like dev video, which are like I want to read, like I want to interact with the graphics card. Those aren't like character devices, like they might be character devices in that they are like implemented as character devices, but like I don't think that that means that you can read and write like words to your video card and expect something to happen. It's more just like I want to do bulk data transfer with this thing from user space. Is kind of how I view it. um all right. All right, so I'm actually like quite happy with this. Obviously, there's like more to do here, right? Like, it would be nice to be able to implement like star and like capture, like maybe like capture groups, like where you can say like A or B, and then maybe it would be nice to be able to do like I want to like mark the start and end of these things so that you can like kind of print them out as like like ANSI encoded sequences that have like colored sections and stuff. So we'll probably do at least one more day on this. But I think that we made like really good progress today. I think that we got to the point where I can title this video, I put a regex engine in the kernel, and I wouldn't be lying. I wouldn't be lying. So, yeah, pretty happy with that. Pretty happy with that. So, thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time. We try to go to around 4 o'clock Pacific time. It's 4:20 now if you're watching live, so any time between 4 hours ago and now is when you can expect to see me live. If you're new here, there is a YouTube link in the Twitch description where you can check out everything else we've been working on. We're kind of like in the middle of a break from our long-term map project, but we'll probably be back on that soon. So keep an eye out for that. But if you want to check out stuff that's maybe in the past, there's like I think QR decoder was pretty fun, video editor people really liked, operating system was pretty fun, neural network was pretty fun. So check that stuff out if you want to. GitHub link in the Twitch description where code for this will eventually go up. So we have this like dev regex repo and as well as like a kernel testing environment. So the combo of these two is kind of what you're seeing me work with today. I think that's it. Like, subscribe, Twitch Prime, etc., etc., etc. YouTube, goodbye, and Twitch, let's find someone to raid.